So, good morning, everyone. My name is Vaishagir, and I am a final year PC student at Government College of Engineering, Kannur. Today, I'm here to present an internship project on IoT-based home automation. I would like to extend my sincere gratitude to my project guide, Jayalakshmi and Daniel, for our invaluable support throughout this journey. So, here is a quick overview of what we'll be covering today. We'll start with a look at the internship itself and the key topics I learned. Then we will briefly define what IoT and embedded system are. And we will dive into the project requirements and the system logic for each module. I will also briefly explain my code before a live demo and finally share my conclusion. So, about the internship. This internship was conducted by Emertex Technologies, focusing on the practical application of IoT and embedded systems. The main goal was to introduce us to real-world IoT applications. We began with a deep dive into C and C++ to build a strong coding foundation, then moved to interfacing sensors and actuators with Arduino. A key part was using the Arduino IDE and Pixim Lab for development and simulation, and the Blink platform to build our mobile app. So the topics that we learned during the internship were C programming fundamentals, covering everything from data types, operators to pointers and functions. Then we then built on this by covering C++ and the core concept of object-oriented programming. With this foundation, we were introduced to the core concepts of IoT and embedded systems, which was essential for our project. So in summary, we started with C and C++, learned to use the Arduino IDE and Pixing Lab simulator, then build the final project in modules. We learned to control an LED with an LDR, interface a CLCD, integrate with the Blink IoT app, and work with the serial tag. So, what is IoT? So, the IoT means the Internet of Things, which is a network of physical objects that have embedded technology, allowing them to communicate, sense their surroundings, and interact with the external environment. So we see it everywhere now in smart home automation system, in monitoring soil moisture, in healthcare monitoring systems, etc. So what is embedded system? So embedded system is basically a computer system, a combination of hardware and software that is designed for a one specific task. So this system is basically defined by the task. Uh, and they are built to be reliable, low cost, and task specific. So the main project requirements or the objective of this project was to build a home automation system that can control garden lights based on sunlight intensity, control a temperature system including heater and cooler, control a water tank with also including its inlet and outlet valves. So the main requirements for this project were in the hardware. For the hardware requirements were mainly the Arduino Uno microcontroller, Ethernet shield for internet connectivity, LM35 sensor for temperature, and an LDR for light, and an LCD for status display. The software part, we use Arduino IDE for coding, Fixing Lab for simulating the hardware, and Blink IoT app for the mobile interface. So, so looking at the system logic, we'll start with the garden light. This is a simple but very effective automation using an LDR. When it's dark, the LDR's resistance is high, and the Arduino turns the LED on. When it's bright, the resistance is low, and the LED turns off. The diagram here shows a system architecture. Our fixing lab simulation connects to the Blink cloud, which syncs in real time with our mobile app for two-way communication. Now, the second module, this water tank has both manual and automatic control. So in manual case, I can use buttons with the Blink app to turn the inlet and outlet valves on or off at any time. In automatic case, the system automatically turns the inlet on if the water level drops below 2000 liters. To prevent overflow, it automatically turns the inlet off when the tank is full at 3000 liters. Now, the logic of temperature control module. In the manual case, I can turn the heater and cooler on or off using directly from the blinker. Or in automatic case, there's a key feature. If the heater is on and the temperature exceeds the threshold of, in this case, 35 degrees Celsius, the system automatically turns off the heater off and sends a notification. So so before going to the demo, I'll briefly explain my code. So my code connects to the Blink cloud using an authorization token. So it's built around functions like build, Blink write, which are tied to our virtual pins. So when I press a button there, like cooler on, it triggers the Blink write cooler V pin function to run. To send data to the app, a Blink timer calls a function called update temperature reading every second. This function reads the sensor and uses Blink virtual write to update the temperature and volume gauges in the app. The main loop just runs the Blink run and the timer run commands. Also continuously calls my handle temperature function and handle time functions to check if any of the automatic rules have been met, like the 35-degree cutoff or a 2000 liter autofill. Now, for the live demo, so this is the this is the fixing lab simulator. I'm loading the file now. So as we can see, this is the Blink application in my phone. So, and as you can see, this is the serial fan. So for the garden light, you can see the LDR module in fixing lab and the LED. Right now, the light level is high, so the LED is off. So if I decrease the light, that is increase the resistance, we can see the LED is turning on. So as I increase the light again, so the as I increase the light again, the LED turns off. Now for temperature control, as we can see, so in my mobile application, when I press the heater button, it is shown that the heater is on and the temperature is rising. Now temperature is rising as you can see, and as it passes, we'll see that as it passes 35 degree, the heater turns off automatically. It acts like a fail switch or a safety switch. Now we off the heater, and it is shown in the display that the heater is off. Now I manually turned on the cooler now. Now I manually turned on the cooler. So the cooler is on. So you can see the fan is rotating and the temperature is decreasing. Uh, Now I manually turned off the cooler. Finally, in the case of the water tank, as you can see, I'll press the inlet valve on my mobile app. The inlet in fixing lab turns on. As you can see, the volume is increasing, and when I turned it off, the inlet valve is shut down. Now I have opened the outlet valve, and the volume in the tank is decreasing. So as I said, automatically, if it drops below 2000, the inlet valves gets opened automatically, and it is filling the tank. So that handle tank function that I have mentioned already is helping in this process. Now, as I've shown the demonstration, so I conclude my presentation by saying that this internship was a very valuable experience. It provided a strong foundation in C, C++, and embedded system. Not only I have gained theoretical knowledge, but also I have had a hands-on practical knowledge in this case. I am comfortable with Arduino interfacing sensors using powerful IoT platforms with Lightning. I successfully developed a fully functional IoT based home automation project. So this basically increased my problem solving skills, my management skills, and also this presentation has increased my communication skills. So thank you all for your time. Uh, so thank you.